We will see today about the fire alarm system. Okay. So normally, the protection system is the one thing, and alarm system is the another thing. Because normally, what happens? We will be installing the system, and how we are going to get like uh, the further information about the fire is because of this fire alarm system. Okay. And if you see in this fire alarm system, the most important, okay, the equipment or appliance, whatever you say, is the detectors. Okay. Because of the detectors only, we are going to get the information. So there are different types of detectors, okay, available. In the first section, what we will do, we will see certain important detectors, okay, which are mostly used in the industry, and there is one NFPA 72 also. So it's a very big book. So we will try to see these two things. But before going to that, quickly we will see something about the detectors. And there are so many things actually related with detectors. I will share it. So yeah, this is the about the fire alarm system. So basically, why we are doing this firefighting or fire alarm system? What is the purpose of fire alarm system? Is to detect the fire. The very first thing what we require is the detection of fire. Obviously, if you detect the fire, you can fight the fire, protect the property, save the life. Okay, these are the certain things which can be followed. So basically, what happens in the fire alarm system? There will be one control panel. Okay, we usually call it as fire alarm control panel. So in this fire alarm control panel, okay, there are so many modules actually. In this fire alarm control panel, there are so many modules connected. So each and every module is addressing any one device. For example, I will just say like this. For example, there are names like M1, M2, M25. I'm just giving one name of the module. So now M1 is representing, okay, the device. For example, this M1 is connected to the detector. So any one detector, whether it is a smoke detector or heat detector, and it is connected in the ground floor, detector in the ground floor. So this M1 will be written in the detector in the ground floor. So like that, this control panel will be having the modules, and each modules will have a different name. So which will be addressing the different devices. So we will see that. And here you can see just one image is drawn. One control panel will be there. If any fire occurs, so there will be alarm, and because of this alarm, control panel will get activated and it will address that particular location. For example, where if the fire is occurred in 5th floor, so it will send the signal to the 5th floor detector will send a signal to the fire alarm control panel, and this control panel will obviously activate the fire protection system. And what is fire protection system? Activation of fire pump, and then supplying of water. Everything is like the fire protection system. And here some features are given here. Okay, some things are given here, but the most important is that our fire alarm system devices should be UL listed and FM approved. So FM global, it should be tested according to the FM global, and it should be UL listed like underwriters laboratory. So the devices or modules or detectors, they should undergo these two certifications. So that will be given by what you can say, the manufacturer will tell you whatever it's like the certification and all. And here you will see the general LED indicator operation. Whenever any fire is occurring, or in the fire alarm control panel, how you are going to understand that the fire is going to occur or fire has occurred in the different floors. Because of this color LED indication points, like green is for the normal operation, yellow is that detector is in trouble and needs, okay, some addressing, and red is alarm condition, and no flash means detector is not powered or detector requires repair. Suppose if the power is not coming means obviously there is no flash, and here some flash intervals in seconds are written. Okay, like it will blink for that particular time. So this is the LED indicator operation. Now we will see something about the detectors first, then we will enter into the NFPA 72. So here you will see there are different ranges are given. So first one is the heat detectors. Now understand this, heat detector is different and smoke detector is different. Smoke detectors are those which will address the smoke condition, and heat detectors are those which will address if the fire has actually occurred and the heat starts spreading in the space or in the room, whatever it is. So here again in heat detector you will see that there are fixed detectors. Fixed detectors are nothing but it is a like alarm when the sensing element reaches a certain set point. So there is a set point, like there is a temperature. If you remember that every sprinkler will have a temperature range. Like for example, 68 degrees Celsius is the standard temperature. Okay, what we are following for the commercial or residential sprinkler system. Like that, for the sprinkler, for the detectors also there is a range of temperature. The common models have 135 degree and 200 degree Fahrenheit. So I think 135 degree Fahrenheit is 68 degrees Celsius only. Okay, 135 degree Fahrenheit or 68 degrees Celsius. So whatever the sprinkler range will be there, the detector range will also will be similar only. So what is the meaning of this temperature means? If the room temperature is reaching, if the room temperature is reaching at this particular temperature, then detectors will start detecting whether it is smoke or like heat is occurring. And with this what happens, just a minute, the alarm will go to the fire alarm control panel. It will activate the fire protection system. This is one fixed detector. Now what is the meaning of fixed detector means? It will only activate at a certain set point. That means if the temperature is reaching 135 degree Fahrenheit, then only it will activate. There is a different type of detector which is called as rate of rise detector. The meaning of rate of rise detector means as the temperature increases, so this detector will adapt automatically. Okay, like respond when the rate of temperature increases greater than an allowable limit. There is an allowable limit 15 degree in 60 seconds. Suppose if you have set the allowable temperature as, for example, 110 degree Fahrenheit. If you have set this temperature, so if the temperature is going 15 degree, okay, like 125 degree, if the temperature reaches 125 degree Fahrenheit, it will start giving the alarm. So this detector is quite what you can say, it is good as compared to fixed detector, because you can manipulate the values. Like if you set the temperature limit to 95 degree Fahrenheit, then after 15 degree it will start giving the alarm, whatever it is. And they have given the examples where you can keep, like in the ovens or heating vents, where the temperature is always fluctuating, so you can keep in this. The rate of rise element is restorable when condition return to normal. Okay, suppose when the temperature increases and then decrease, it will become stable. Rate of rise detectors. A rate compensation will respond regardless of the rate of temperature. Okay, there is one more, linear heat detection cable. Normally this linear heat detection cable is used by electrical people. So like it is a cable which cannot catch fire. Okay, like literally this cable is used in the high hazard areas. And again here they have given two types, analog and digital. Combination detector have both fixed and rate of rise. Fixed element detection at 135 degree, the rate of rise, okay, something is given here. Definition is given here, linear heat detection. Continuous heat detector in the form of a cable. It will be act like a cable. Like you will not see any detectors, but the cable will be running. Okay. Digital means point of risk heat detector. Okay. LHS cable, linear heat sensing cable. It is continuous heat. Analog type, average heat detector, rate of rise. Here they have just given the temperature ranges, like minimum temperature is 35 degrees Celsius, maximum is 105 degrees Celsius in the analog type. And in the digital type, the minimum temperature is 61 degrees Celsius, maximum temperature is 230 degrees Celsius. Length, maximum length is 10,000 meter in the digital LHS cable. In the analog LHS cable, it is 1000 meter. Only this difference is given. And here some images are shown, like what is the conductor, what is the insulation, what is the sheet. So these things are given here. And applications are given here. This is also the most important point. Application for only LHS cables. This is the applications given. And temperature ranges available in digital. Different ranges are given here. What is the benefits, advantages over the detector system? If you are installing LHS cable over detectors, what is the advantages? It is shown here. Provides hazard coverage at every point on the cable. Easy installation, maintain minimum false alarm. Conventional fire alarm panel available in variety of lengths. Okay, so many things. So this is something about the this type heat detectors. And after that, here you will see one more device called as manual call point. Okay, so in this manual call point, what is the meaning of manual call point? Means like whenever you want to give an alarm, for example, your building is very big and you want to address to the every people, okay, like in that floor. So what is the best option? Just break the glass and hit the call point so that it will be connected with the alarm. So what happens, everyone will understand that something has happened in this building, so they will start running towards the fire exits. So this is the manual call point. In an event of a fire, break the glass of the nearest MCP that you have located, that will sound the fire alarm throughout the building. So you have to place certain manual call points at certain places. And after that, fire detection principle manual initiating device. So this manual call point are also sometimes called as manual pull station. Don't get confused with this manual call point or manual pull station. A ready identifiable means to activate the building fire alarm. A manually operated device used to initiate. Something is given here. Initiating devices, manual fire alarm station, manually operated devices used to initiate, and single action station require a single operation. See, everything it is talking about the manual call point only. Whatever the things we are seeing here, positioning of manual call point. This is also some important point. Manual call point should be located on escape routes at all exits to free fire air and at all exits from each level of multi-story building. So it should be installed in the escape routes, like we will have a fire exit escape route. So we have to place MCPs there, and all the exits near the door we have to install. In general application, all points should be located such that nobody need to travel more than 45 meter. So this is the most important point. Every 45 meter you have to install the manual call point. This is what this particular point is telling. To reach the nearest call point, this distance is based on measuring the actual route.
Sir,
Yeah.
hello. This criteria is there any codal requirement? Does this any mention?
I think in NFPA 72, if you check in NFPA 72, it will be mentioned. So we will see that NFPA 72 also. It's a very big book actually, NFPA 72. So we will see that book also after this.
Okay.
And the distance is based on the measuring. Okay, some things are given here. Okay. So certain points are given here, like what is the height of the manual call points. And here it is telling that from 30 meter to 45 meter, we have to follow the distance between two manual call points, MCPs. And here one image is also given, just drawn like this is the manual call point. Okay. And how it is kept, how we have to install. This is something given, and here one example is given here. How to position the manual call point. See here, you can see there are 3 rooms, one canteen, one kitchen, one pantry, one office. So manual call point should not be installed inside any room, but it should be installed in such a way that if you install in these 2 places, everyone can listen here. But for kitchen also you can install MCP, because kitchen is also a high hazard area. In case of fire, there are likely the chances are there that because of our gas cylinders or because of our ovens, the fire can catch, what you can say, it can catch very easily. So that's why one you can place in the kitchen also. And how you have to place the height of the call manual call point should be such that it should be like it should be, or it can be used by a small boy also, because in case of fire, what happens means, like if you place the MCP is 6 feet 7 feet high above the floor, then who is going to use that? So we have to maintain this height also. Like I think 3 feet is maximum, 3 to 4 feet we have to keep the like MCP's positioning. So it is telling this thing only, and somewhere it will show also general guidelines for call point. Call point must not be more than 30 meter apart, be mounted at a height of 1.4 meter. Okay, here it is telling that maximum 1.4 meter it should be there. 1.4 means it is almost 5 feet is the maximum, but it's better to go 4 feet to 5 feet. Be mounted against contrasting background. That means if you have any contrast background, for example, the manual call point is red in color, and if your wall is like dark blue, dark purple color, no one can see that manual call point. So try to find any location where it can be visible clearly by everyone. And again, one like pie chart or one classification chart is given for the fire detector. One is heat detector, one is smoke detector, one is flame detector. In heat detector, there are point detector, linear. In point detector, fixed rate of rise. In linear, integrating, non-integrating. In smoke, line detector, point detector, duct detector. This is general classification. Flame, ultraviolet, infrared, okay, detectors. And this is one image for the fire alarm system. So this is the control panel. So to this control panel, first you have to give the AC power, battery. Okay, this requirement comes from the electrical team. And siren will be connected. Okay, siren will be connected to the control panel only. Okay, and this is the system. Like I told you, like some numbers you have to give, module name, or like to address the system. So that thing is given. Just one image is given here. Great computerized aided. Okay, sometimes they use the like this kind of system also, but nowadays I think they're using FSCP only, 8 loop, 16 loop, whatever the like FSCP is. So this one is the previous one actually. So something is written here. Intelligent modules. Now we are remember that there are so many accessories in fire alarm. So till now we have seen something about the detectors. Okay, and something we have seen about the MCP. So these are detector, these are what you can say, these things are uh, equipments or appliances which is used in the fire alarm system. Okay, 1 minute. Intelligent modules. What is the meaning of intelligent modules? Means these are designed to meet a wide range of application, monitor and control module. Now next will be the monitor module and control module. You will hear this term also, monitor module and control module. Okay, this is also one of the device which is used in the fire alarm system. Now here it is talking about the both combined together, it is called as intelligent modules. If you are telling module, intelligent module, it is monitor module and control module. And there is a company called as Secutron. Secutron's intelligent module products are designed to meet a wide range of application. Monitor and control module can be used to supervise and activate sounders, strobes, doors, water flow switches, conventional smoke detectors, and more. This is some important point. So these modules, how it will be there means, uh, these modules are connected. These modules actually are monitoring. Okay, like just understand that there is a class monitor. Okay, like class monitor is monitoring a class of 50 or 60, and he is addressing the problems of the students, like whatever the problem, or if anyone is doing some problem, so it is addressing. Like that, this monitor module and control module are monitoring for control panels. Okay, so this monitor module and control module are actually sending the signal or information to control panel. Okay, so I think for every detectors, like for some 50 detectors,
Sir, hi.
monitor module will be connected. Yeah.
Sir, regarding one question related to control modules, how can we trip the any equipment in HVAC system or in fire system in case of fire?
Tripping, actually, I don't know about that thing.
Okay, Mr. Atif, can I answer him because I'm from alarm engineer?
Yeah, yeah,
Yeah,
yeah.
yeah.
For the control module, you have to interface with fire motorized damper. In case of fire, you have to shut down these things. It is in the fire smoke management system. As well, it has to activate the pressurizing staircase fan. I think Mr. Atif is HVAC, you understand. And the lift pressurizing fan, it has to start it. It will give signal to the controller panel of these fans. It will be activated. Also, there is input module.
Okay.
For example, FM200, if it is released, it will tell the fire alarm panel through the monitor module. It will give dry VFC, voltage free contact. Okay.
Okay, okay.
And the zone control valve for the firefighting. We have seen this the past week. Zone control valve, and there is a float switch. It has to be interfaced with the monitor module. If you close the zone control valve, it gives you alarm because you cut the water on the sprinklers. If there is a fire on the floor, the float switch will tell the fire alarm we have a sprinkler release. Okay.
So you are
These
okay.
interfaces, majority of interface. Also, we have for ventilation inside the car parking, we have fire. We have make up pressure fans. This is for the fresh air, and there is fire smoke ventilation fan. In case of fire, it will be activated, or CO, carbon monoxide, ppm is very high. It also will be activated through the fire alarm.
Yeah.
Okay.
Yeah, you can, but
Okay,
like
okay.
normally, if you see in HVAC, we go with the dampers, fire dampers, but
Yes.
it's up to like the project and it up to the cost of the project. You can connect this system with the fire alarm system also, but usually they don't connect because what happens if you are connecting the HVAC equipment with fire alarms a system, so you should have the knowledge of firefighting and you should have the knowledge of HVAC, which normally doesn't exist like in most of the running projects if you see. So that's why what they will do, the HVAC team will be working separately, firefighting team will be working separately. Only they will coordinate if any pipes or ducts are crossing. Otherwise, I think in the BMS, and if
Mr. Atif,
BMS, they will connect.
Mr. Atif, in Gulf, it is recommended what I have
Okay,
said.
it is, yeah, but here it is.
In
I
Dubai,
think
in
if,
Abu Dhabi, it is strictly recommended.
yeah, if they are going with the BMS strictly, then obviously everything will be connected through BMS. If they are going with BMS, because
Not the fire and safety. BMS will, in case of fire, the elevator, the lift has to come down to the ground floor and open the door. This through the
okay,
fire, not from the BMS. BMS will
okay,
take
okay.
only feedback, monitor and feedback. That's it.
Yes, yes. Okay, okay. So next you see after this, basically it is used to supervise, and there are three things you can understand fire alarm system. The very basic thing is this is the input, this is the fire alarm control panel, this is the output. Okay, so normally what is the input, what is the output, that we need to understand. All the like horn strobes or any like manual call points or whatever the things you can see, this is the input points because we are getting the input to the control panel. And the output, what will be the output? Like output will be like whatever this control panel acting, like based on the input alarms or based on the input information. So that will be the output. Like output will be obviously will be like for our whatever we are putting, like we are keeping our efforts fire protection system, that will be the output. So basically this control panel is the most important in fire alarm actually, because whatever the input you are connecting, everything should be connected with the control panel in a very proper looping system. If you missed out any one place, then what happens, whole design, okay, design will not fail, but if unfortunately if fire occurs in that particular space, what happens, they will like blame us only that you have not connected any sensor or detector system there. So like that there will be there. And here it is telling something, each module is rigorously designed and tested for electromagnetic and environmental reliability. Okay. Alarm signal as per NFPA 72. Actuation of alarm notification appliance or emergency, voice communication emergency. Okay, some things are given here. Shall occur within 10 seconds. NFPA 72 is telling that within 10 seconds, your alarm should activate. Whatever the system you are connecting, whether it is a automatic system, conventional, okay, not conventional, automatic system, it should activate 10 seconds after the activation of an initiating device. After that, this is the basic system. Like I told you, inputs and there is a outputs. So there will be the inputs and there will be the outputs which will be generated in our computer and all, like the fire has occurred in that particular position, or it will blink red color, whatever it is. And the types of fire detection system. There are 3 types of fire detection system: conventional, simple addressable, advanced, intelligent, analog addressable. Now, why it is called as addressable means because we understand that this control module, monitor module, detectors, or any fire alarm control panel, it is addressing the device. Like as I told you that at certain floor, 3rd floor, 4th floor, if any detector is blinking, it will address that issue. That's why it is called fire alarm system. Conventional means, in conventional what happens, you have to check, you have to go to 3rd floor and you have to check whether the fire has actually occurred or not. So this is the conventional, or you can simply say that it is a manual method. Conventional method is a manual method, which is not at all recommended. Nowadays, the conventional method is not at all, what you can say, recommended. I think only you can use a conventional system in those areas where that particular area is visible to supervisor. If any supervisor is there or any fire officer, if that area is visible, okay, he can understand by seeing that if fire occurs, they can go and pull out, switch off the valve or anything, whatever it is, or switch on the valves, then it is okay. But you cannot use this conventional system in a high-rise tower, 5th floor, 6th floor, 25th floor, and in a very like closed space, we cannot use. Simple addressable is simple addressable, very simple system. Analog addressable is a complex system. So these are the intelligent. Nowadays, this analog addressable systems are going on. There is one radio type also, but I think, I don't know where they are using this radio type. Maybe in the Navy system they are using radio type and all, or maybe in those areas where they can get some frequencies from the radio system or and all. But this one is the analog system. Analog addressable fire alarm system is the most common nowadays, and it is little bit costly also if you compare with the conventional. Some zoning system is given here. Now in fire alarm system, we have to create the zones actually. Like how to create the zones? Simple. How to create the zone means based on the loop system, we have to create the zone. For example, fire alarm system will be 8 loop, 16 loop. Okay, I will just show you. Fire alarm control panel. If you check fire alarm control panel, it will always ask you what type of loop, 2 loop, 2 zone, 4 zone, 16 loop, like that it will show you. So based on that we have to do. So I am just checking anywhere it is given or not.
For what?
See here it is written 8 zone fire alarm panel. Sometimes it will be written as loop also, 16 loop, or anything it will write. Here it is not written. Here also it is. See, 4 loops. 4 loop. Sometimes zone, sometimes loops. It will be written. So the zoning is very important in fire alarm system. See, sprinkler zoning is different. Fire alarm zoning is different. In sprinkler zoning, how we are doing? We are differentiating the sprinkler zone with the help of zone control valve. Okay, like we have kept one zone control valve and that floor is one zone. There are 10 floors, 10 zones. But in fire alarm system, the zoning system will be different. The zoning will be done based on the detectors, okay, and based on the monitor or control modules, or based on the devices. Like if you are connecting these many devices, so this much of what you can say, this is one loop or one zone. So like that, there are certain limitations given, which will come in the next slides. So here they have given what is allowed, what is not allowed. You can create zones like this, half of portion. You can create zone like this, half of portion. Even you can create zone like this, one room, completely you are taking one zone, and this outside you are taking one zone. But it is not recommended like this. If you are taking half zone for zone 1 for this, zone 2 for this, zone 1 for this, zone 2 for this, not like that. Even this is not allowed, zone 1, zone 2, zone 3, zone 4, because you can avoid the zones here. So you have divided into different. So like that, some things are given here. So this is just a different thing. And next important thing is given here, standard detector spacing. How to space the detector? Like as sprinklers detector space, as sprinkler spacings are there, in the same way detector spacings are also there. So here two ranges are given. Either you go with 6.1 meter or 9.1 meter. For heat 6.1 meter, smoke 9.1 meter. Between two, what you can say, detectors. The distance between two detectors, but normally what happens, we follow the site conditions because there are so many coordination issues will be there, and you have to check those coordination issues. And in NFPA 72 also they have given about the detector spacing. We will see that also. And some things are given here. Just leave this. Positioning of smoke and heat detectors. To ensure of complete coverage, spacing between detectors should be reduced to 10 meter between smoke and 7 meter between heat detectors. Okay, leave this. Some things are given, but understand this thing only. Like 6.1 meter for heat, 9.1 for the smoke detector, which is
Sir,
center to center, detector center to center, right?
yeah.
Sir, one more question. Uh, Instead of using two detectors, smoke and heat, can't we use single detector for both the
Anything you
applications?
can use. Multi-detector also you can use. Multi-detector, smoke detector, heat detector. See, there is one more document also. I will share here. You see there are different types of detectors given here. So just you can go through this document also. Just they have given about the detectors here, like how some images they have given. So this document will be also helpful for you. So here they have only given about the fire alarm control panels, and some detectors also I think they have given with the proper images. Smoke detector, heat detector, or multi-detectors also. Everyone is using multi-detector actually nowadays, because in multi-detector it will act as a both smoke and heat detector. And these detectors, I think it costs very like 500 to 600 rupees, I think, one detector, or depend upon the classification of hazard, the detectors also changes. I just told you the rate is very like for a very general or common detector. Some positionings are given here. Ionization, one type is ionization smoke detector also. What is the meaning of ionization smoke detector? It senses a product of combustion particle. Now whenever you are using any micron level, uh, like if you are doing any micron level projects like clean rooms, where the microns are very important thing. For example, like if you are a pharmaceutical company, and where you are like you have very minute particles. So I think those for those particular places, ionization smoke detectors are very helpful. What is the principle of ionization smoke detector? It will work as a radioactive source which is sealed within a reference chamber. There is also a radioactive source emitting from the sensing chamber. I think one image is given somewhere. No, it is not given. Something is written here. When carbon particles from smoke come into the sensing chamber, they change the speed at which the radioactive ions move around the chamber and the fire alarm signal is given. Here they have given the advantages and disadvantages of ionization. Good detector early warnings. Disadvantages is that because of the radiation, radioactive, the radiation, chances of radiation is very high. Expensive disposal, radioactive source, okay. And some things are given here, clean air, current values and all, some images. You can also get some information about this ionization smoke detector from internet also. There are a lot of documents given here. And smoke detectors, there is one more detector called as photoelectric detector. Suppose if you are if your building is having more lights, like because photoelectric deals with the light system actually. And here they have written also the light from the light source on the left shoots straight across and misses the sensor. When smoke enters the chamber, however, the smoke particles scatter the light. Here you can see how this particular, suppose this is the light source and B is the photo sensors. Whenever the light is passing here, so this photo sensor will be like cutting this light source, and because of this light source temperature, it will understand. If this light source temperature is very high, if it is critical, then it will analyze that something is happening, smoke or heat, so it will again alarm the signal. Like that it will happen. And here also they have shown how it will cut. This is the light source, this is the photo sensor. Ionization versus photoelectric smoke detector. If you compare these two, so here some examples are given. In the ionization, the air will be clean, but in the photoelectric, the air will be contaminated. The radioactive material releases charged particle into a chamber and a small electric current flows between two poles, two plates. Some things are written here. I think you can see here how these detectors will act here. Detector with smoke, detector without smoke. So this is the light beam passing. So those things are given here. What is a fire alarm? Okay, elements of a control panel. Fire alarm system can have a variety of input devices. Now here input devices are smoke detector, manual pull station. Output is horns and strobes. Okay, here it is given like that. Once the signal has come from the detectors, so what happens? Next thing, what happens? We have to like give the horns or strobes. Like we have to how you can say, suppose this input is coming from the detectors. Okay, like detector is sensing some heat or smoke is coming means. So what happens? This control panel will automatically give the alarm here with the help of horns. Like in the horns, what they will do? They will just announce that something is happening in that particular floor. Please evacuate the building, something like that. So here they have explained in this manner. Inputs are detectors or manual call points, and outputs they are telling that the horns and strobes will be there. Types of fire, again the same thing has come. Conventional, simple, addressable. Alarm devices fall into two types: audible and visual. The audible type are most common, with a variety of type being available from bells to all kind of different electronic sounders, including those. Okay, there are two types of alarm devices. One is the audible. So all the bells, speakers, sound, horn, strobes, I think everything comes in the audible. But let us see what is the visual. The choice of devices depend on local preference. Okay, speech alarm or link to PA system. Visual is nothing but the PA system, speakers, because we can give the alarm with the help of speaker also, and speaker is a visual one. Or the PA system. Overcome some of the complaints. Okay, some things are written here. You can just check here. Here it is telling that BS583 require that alarm circuit should be arranged such that in the event of a single fault, at least one sounder operates within the vicinity of the control equipment. Or in the case of certain building open to large number of the general public, a single fault only partially reduces. This point is also a little bit important written here. They have given the minimum criteria for the alarm, fire alarm system. And here they have also given somewhere the decibel value also. And after that, sound levels. Here they are talking about the sound levels. Sound levels should generally be 65 dBA or 5 dBA above persistent background noise level. This may be reduction to 60 dBA. I think you will get one table here. One sound, see here, this is the table. Decibel sound pressure. A user, common listener will have a up to 40 decibel dBA is given. For 60, it is given to computer. 80 is given to car. 120 is given to aeroplane. So this is some decibel sound pressures are given here, and something is written here. Sounder output levels are normally quoted in dBA at 1 meter. The graph below can be used to calculate effect of sound at other distance in air. In addition, allowances have to be made for obstructions such as door, the absorption of sound furnishing the directional nature, the sounder mounting peak and location of the sounder, etc. Some values are given, distance from the source you have to multiply actually. Something is given here, but this is the actual table for the decibel value. Now here you have to understand one more thing. If a person is sleeping inside the room, so there you have to go little bit higher, like with a decibel, sound decibel, because what happens, a sleeping person can never hear uh, the alarm. Okay, whatever the alarm or whatever the horns are ringing, you have to go with little bit louder decibel values. So that thing is written here. Somewhere here it is written about the where sleeping people are to be woken, then 75 dB is required. Normally we require 65 dB, but for sleep
65 the civil difference
yeah,
requirement 65.
for sleeping people, just add 10 dB because they will be in the sleeping position. So whatever you are installing near the bedrooms or sleeping area, so this should be 75 dB. And here it is also telling a loss of 330 dB per door should be allowed for to guarantee 75 dB, because this will be door, it will be closed. So here you have to consider the loss of 30 dB also, because maybe the door is very heavy, thick door. So maybe that person cannot hear the alarm. So here it is telling that loss of 30 dB. That means you have to consider 30 dB plus 75 dB, 115 dB. Yeah, but before that, you should check the condition of the door also, whether it is a very hard door or small door, thin door. Everything should be considered. Certain points are written here, and outputs. Some things are given about the outputs, like alarm sounders, distinct from other type of warning and continuous ringing time of the bell. Alarm occupants about the position. Okay, some things are given here. Audible devices about the bells, horns, sounders, some definition, chimes, sirens, speakers, visual signally appliances where high noise level exists, visual indication. Some things are given here. Now here it is talking about the beam smoke detectors. Suppose if you are going with the beam smoke detector, how it will be there. Some principle I think it will show here. Projected beam detector, a type of photoelectric light obstructors wherein the beam spans the protected area. So maybe this is the light source, it is passing here, and smoke particles will be there, and there will be two sources. I think one source, one is the receiver. So here if you install this beam detector, so basically they will extract the smoke particles actually. That's why here it is written clean air. So maybe the smoke particles will be extracted. And here also they have given one image for the beam smoke detector. Smoke from the fire in the protected area diffuses the intensity of the beam at the receiver end. There is a transmitter, receiver end. From the transmitter means the light source is emitting from here, and here it is receiving. If the fire occurs, so the light will be diffuses, or it will be divert. Okay.
Yeah,
Things
there is regulation. There is
Where
regulation.
it can be used?
I think this can be used in any projected screens or anywhere. They can. These are very
No. These beam detectors are used above heights inside 9 meters,
okay.
and especially in warehouses, in factories.
Warehouses. Even that, what you can say, where multiplex and all, like theaters also, I think they can use this one, because the heights of the theaters are also very high only. But this
So majorly the height does matter.
height matters. I think it will
Yes.
cost 50,000 to 1 lakh.
Wherever you have height of inside, more than 9 meters, go for beam detectors.
Here they have
Don't
given.
go
See
for
here.
smoke detector.
Here
Because
they
the
have
smoke
given
detector, it has a spacing factor with height. It will be less
15.
efficient.
Okay.
Here it is given 15 meter. Okay, here they have given the 15 meter. Just one thing is given, receiver unit, transmitter unit. So something image is given, location and spacing of fire detector. Okay, this is also one important section here. Optical beam detector maximum permission coverage 1500 square meter. Maximum ceiling height 25 meter. Beam should not more than 600 mm from the ceiling. Some images given here, like some height ranges are given here. Fire alarm system design. Call points to sounder, sounder to control panel. control panel to detector to high risk area to the detector everywhere. First, what happens? Call points will be activated. Okay, then sounders will be like happening. Control panel, detector to high risk area, detector to everywhere. Something is written ML3, L2, L1. Some things are written here. So this is just ceiling heights and spacing reducing factor. Ceiling height multiplied by reduction factor. Okay. Here what they have given mean this particular, if this is the ceiling height, you have to multiply with a reduction factor for the spacing positioning of smoke detector. And this particular point is given as the maximum coverage for smoke detectors. Whatever in general, the maximum coverage of smoke detector is 100 square meter, maximum ceiling height is 10.5, maximum distance from any wall is 7.5, minimum distance from wall is 0.5 meter is given. Some things are given here. So this is also important point. Detectors should never be installed at location where ceilings and wall meet, generally referred as dead spots. Since this point is little bit important, that's why we have highlighted in red. So what is the meaning of dead spots means? Suppose this is our ceiling, for example. So there are 4 dead spots. 1, 2, 3, 4. Sometime what happens? The rooms will be in triangle position. Okay, like it will come in a triangular position. So here what happens? It will act as a dead spot. So we should not install anywhere near here. This is what it is telling. As very little air flows and particle of smoke will bypass because of the structure of the building. This is the spacing for the smoke detectors. In the same way, this is the spacing for the heat detectors. And here also some highlight point is given. These are generally devices of 80 which are used in kitchen, boiler houses and other appliances. Some things are given: maximum coverage, ceiling height, maximum distance from any wall, minimum distance from any wall. So you have to follow this particular for the spacing of the this one, and how to select how many sprinkler detectors are required. The maximum coverage is given, or as per the site condition. Suppose if you have 100 sprinklers in one room, go for 80 detectors. Just try to cover each and every space, because everything happens in a like in this way only. In India, usually we follow the site conditions only. Types of automatic fire detector. Okay, again the same things will come here. Ionization, smoke, principle of ionization, fire detection principle, automatic detector. Something is given here about the photoelectric system. This also you can see method of wiring conventional system. How this wiring conventional systems are connected. Some things are given here. Like HF is fixed heat temperature heat detector, sounders, ionization smoke detector, control panel, how it is connected, method of wiring for an intelligent analog control panel. Some things are given. Okay, this thing is actually done by the electrical people, not for us actually. And here they have given the cable sizing. The minimum cable recommended cable size is 1.5 square mm actually for each and every detector. Okay, because detectors are connected with the help of cables, we have to go with 1.5 square mm cable. One core, 1.5 square mm cable. This is the minimum cable size. Yeah.
How can we determine 1.5 square mm cable?
This is done by electrical people actually.
Okay, I can answer
if we
answer
are
this
using,
question.
yeah,
Can
yeah,
I answer this
definitely.
question?
This is
Yeah,
the
Or
very
what
this is the very
if you
small. This is the
okay, if
basic
you
size
select
actually.
if you select 1 mm fire rated cable, it will cover 800 meter. If you select 1.5 mm, it will cover 1.2 kilometer. The loop. Okay.
no,
Yeah.
no, no. What I'm trying to ask you, sir. If we connect multiple detectors, number of 10, 15, 100, so there definitely there will be the increase of the cable sizes because of the voltage or anything signal.
The voltage in the panel is DC between 18 and 24 volts. Okay, between 18 and 24 volts for the fire alarm control.
Yeah. Actually, see, this 1 square mm and 1.5 square mm is the very basic cable sizing. This just understand that this is the very first size, which is like this is the starting size actually. This is the starting size 1.5 mm, one core 1.5 mm. So in market, if you go, you will find this size only, the initial size. For example, if you are talking in HVAC, what is the initial capacity? Like we will say that 0.5 TR. If you go to market, you will get the 0.5 TR equipment like that. This is the like common size, or this is a very basic size which is available. Okay.
You mean half ton? You mean half ton? Half ton, right? Half ton.
Yeah, half ton.
6,000
Example.
6,000 BTU.
Yeah. So here they have given detection cable is different, sounder circuits are different. Means the one which is connecting to the sounders, horns, MCP, manual call point, that sizing is, again the recommended sizing is 1.5. Maximum cable size is 2.5 square mm. If you are going for the maximum cable size here, go with the 2.5 square mm. Minimum or recommended is 1.5, because 1 square mm is the minimum cable size which is available in market. Below 1 square mm, nothing is available. But recommended, they are telling 1.5. Now, one image is given here, how this system is connected. Input output module, multi detector, series detector, some things are given here. And here also you see one control panel given, how the different zones are connected. Zone 1, zone 2, zone 3, zone 4. Certain things are connected here just for showing purpose. And here also it is connected. Fire alarm, loop 1, loop 2, how it is connected. So whatever the things you are seeing, this is the cable only. It is connected with the cable only. And here the names are written: SMA, smoke detector, heat detector, isolation, break glass bell. Okay. Addressable fire alarm system, how it is connected. Alarm point, addressable heat detector, addressable smoke detector, addressable input module, and addressable pull station, addressable smoke detector. Some things are given here. And some points are written here. You can just check zone 1, zone 2. I want to show you one important point here actually. This thing you can leave here. Okay, here they have shown about the duct smoke detectors also, how the duct smoke detectors are connected. This is the duct. Inside the duct, here we have to place somewhere detector, and the duct sizes, okay, these things are given.
But sir,
Yeah.
why we are providing, or why we should install the duct detector?
Again, it depends upon the client budget, and if they are designing for a very high hazard area, they should go for extra precaution, extra protection. So that's why
Okay.
dampers
Okay.
are okay, but
No. There, both can answer this question. There is, in case of fire, the return duct, the return duct will
yeah,
carry the smoke inside. These two
yes,
probes of the duct detector, it will sample the air. It will catch the particles of the smoke. That's why we
exactly,
need this smoke detector.
exactly.
Okay.
Here it is given also the operation. Air passes from the sampling tube through the sensing chamber and out the exhaust tube. Air enters the sampling tube stratified across the ductwork. Air then is exhausted through the exhaust tube. Something is given, and recommended placement is also given, where you can place the duct detectors. Photoelectric detector mounted in housing. Yeah, again, it is given something. You can leave this thing. Advanced fire protection. There is one more system called as VESDA system, very early smoke detection apparatus. This is also one of the special system. So here what happens normally means, it will be like aspirating device actually. So these devices are used very latest technologies, most advanced. This is also one type of fire alarm system only, but it is a entire separate system. Like how fire separation system is also a fire protection system, but it is an entire separate system. In the same way, this VESDA system is also a fire alarm system, but it is a separate system, and it's the most advanced technology smoke detection equipment in the fire. VESDA smoke detector hold more certification than any other aspirating smoke detector in the world. What happens here? The detector that consists of a piping or tubing distribution that runs from the detector to the areas to be protected. An aspiration fan in the detector draws air from the protected area back to the detector through air sampling ports. I will show you. It also looks like a panel only. The VESDA system. Vesda fire alarm system. If you see, it also looks like it looks like this one actually. See, this one is also Vesda system only. So this is also a new system. Very early warning detection system, VAWDS system. This is also one of the, and here some costing is written in Indian rupees. View very intelligent early warning, harsh hostile area sensor head, acclimate plus. These are some systems actually. The latest advanced technology systems are given here. Multi-sensor detectors. Now, multi-sensor detector means it can be act as a anything, heat, heat, ion, smoke, anything. It can act as a this detector. Some things are given here. Filtrex photoelectric detector. Again, this is also a new technology. Flame detection types, UV, IR, flame detectors. So these things you can go through that. So many things are given here. Some images. Okay. Like integrated fire and gas system. Some systems, and this is the important point here. Now I wanted to show you this important point. Now here what happens, how to decide the loops. So in the loops, you can see if you are going with one company called as Morley, if you are going with the Morley panel, maximum they will have 5 loops. In one loop, they will have 99 devices and 99 modules. So module means control module, monitor module. These are modules. Devices means sensors, detectors, MCPs. These are the devices. If you are going with the notifier, notifier is a Siemens company. Okay. If you are going with the notifier panel, maximum 10 loops, and in each loop, there are 159 devices and 159 modules. If you are going with Edward panels, it will be 20 loops, 125 devices plus 125 module. So this is a little bit budgetary. Edwards notifier is little bit expensive because there are only 10 loops and there are almost how many 300 devices. So 3000 devices can be connected here, but if you see here, there are 250 devices and 20 loops, almost 5000, and here there are 200, almost 1000. So this is also a little bit like budgetary only. Notifier is little bit expensive, but it is the best quality. I think notifier is from the Johnson Control. If you search here, just search.
And sir,
For you.
about the simplex fire alarm panel?
See, these are the very famous actually. Notifier fire alarm. Actually, it is Johnson Control. I think Honeywell. Sorry, it is
Notifier is Honeywell, sir. Yes.
Honeywell. Honeywell.
Yes.
Everything is Honeywell only. Morley or Edward also. There are only very few competition actually in fire alarm. Honeywell, Siemens, Johnson Control, JCI. These are the three which I know. Both Morley and notifier will be programmed using dongle. Notifier detector will be addressed using the dual switches. Whereas in Edwards will be programmed using barcode on the detector panel. So it is showing the operation. Cylinder. Okay, this thing I don't understand what is written here. Just some points are written here. Ethernet clients, total building system. Okay, these are the some things written here. So basically this thing you need to understand. Now I will show you one layout here. You will understand how this fire alarm systems are connected. So this is one of the project, and here you see the riser diagram has been shown here. Fire alarm. Just a minute. See here how it is connected. MVACP. This is, see here. This is a 8 loops. This is a fire alarm control panel of 8 loops. That means there are 8 loops coming out of this particular panel. And here you can see in each loop there is a incoming, there is a outgoing. That means you are transmitting the signal and you are getting the information. Let us follow one loop here. Suppose I follow this loop. 1, 2, 3, 4, 5, 6, 7. 7 can be seen and 1 is standby, I think so, or 1 is dummy. So if I follow this one, this signal, let us see where it is going. This signal is going somewhere in a very top, I think so it is going. See here it is going. This is the loop 7, and here you can see it is connected with certain things like C1, S, IFU, MS, ESF, S. Some things are written here. You can see it is connected here, and again it is following this path, and it is connected here IB. So last one is the IB. Then this is going back. Okay, again it is going back to the main control panel. Now let us try to understand what is CS from our legends. Somewhere we will have a legend drawing also. From there we will
See,
do
should be
abbreviation. C
should be
is
sealing a speaker. Check it.
C should be the control module. I think C should be the control module.
CS sealing a speaker. It should be.
No, here it is written actually.
CS or CM?
CM is control module. See here, CS is given control module. See, you will understand that S is speaker. Okay, S is speaker.
I told you sealing a speaker, boss. C means sealing a speaker.
No, not
Calling.
Yeah, I think this is calling point. C is calling point. S is not speaker. It should be the detector actually. Why means because we are seeing the FSCP panel. We are not seeing the speaker panel. This is
C means call point. If this one, this call point, and S is the smoke detector, and this is the number, is the address.
yeah, that is the addressable number. I think in this layout is written, not written.
Sir,
Where you have to check. Let me check. Yeah.
First point should be loop isolated.
Here they have written. See.
sir, one more question. If I kept the panel on ground floor, panel on ground floor, and one zone and one loop is coming from 10th floor, 9 to 10,
1
9 to
minute.
10
Yeah, please tell me.
Yeah, so one zone is coming from 9, 10th and 11th floor. So there will be the huge length of the cables and huge length of the elevation difference. So
No.
definitely there will be the signal losses. So how it will be eliminated?
That's why you have to connect to the loops actually. So even that thing I think will be taken care by the electrical people, because they will be doing some voltage drop calculations or anything. Okay, let us see. Let us follow one loop first. Then we will see if here you see abbreviations are given. S is for the smoke detector. C is the
For
manual
that
call point, control module,
Don't go
control.
for more than 4 floors. Don't go
Sorry?
for each loop more than 4 floors.
No, only I am showing one loop only.
Yeah, one loop. Don't go in one loop more than 4 floors. It will cover maximum 4 floors.
I think so, because the lengths are actually it can go, because I have seen in one of the project, like I think 1000 meters they can connect, because one of our guy told that
I told you 1 mm, 800 meters, 1.5, 1.2 kilometers, 1,200 meters.
1002, yeah, 1000
Or 1.5.
actually. Here you see which we were checking, anyone. See, C is the call point. These are the detectors. MS is the monitor module. Okay, now you see the monitor modules are connected in each line. Just observe this monitor module. This monitor module is supervising this particular loop. Okay, this particular loop, this monitor module is supervising, and you can see there are so many devices connected here. Somewhere they have written ESF also. I think this ESF also is the smoke detector only. Somewhere heat detector, smoke detector. Okay, IB, isolation base. Maybe this is the last, like a zone control or any controlling. So suppose if any problem in this loop, so maybe they will come here and they will check which wire is missing or anything like that. And at different places they have placed the call points also. And here you can see the monitor module, and here you see one device they have connected interference with flow switch. So maybe this flow switch is coming near the zone control valve, where they have mentioned here So because of this particular device only, I think the water, like the sprinkler is activating. If any, what you can say, because there will be one sprinkler valve is also connected in our main header line. So maybe this IFU or interference will connect with that particular. There is one control module also. I am trying to see the control module where they have connected. Everywhere you will see one monitor module, you will see. This MM is nothing but the monitor module only. For each loop, it is connected here. But there will be one control module also. It should be connected because control module is controlling monitor module. So we will try to see somewhere here. And here you see the cable size. What they have used is 2 core. Why they have used 2 core? Maybe there are 2 places, or maybe they are like 2 cores are going, or one for the neutral, one for the like phase. That's why they have selected 2 core.
No, this is DC plus and minus. Plus, this is DC plus and minus, not AC. This is DC plus and minus. Each loop have a plus and minus.
Oh, yeah. Exactly. So I don't find anywhere they have used the control module, but you can see monitor module. It is a supervising device. So first level of supervision will be done in this monitor module. Second level of supervision will be done in fire alarm control panel. This monitor module and control module is specifically for detectors. But if you install this device, so this device is specifically for the sprinklers, because it is connected with the zone control valve and with the flow switch. So with these 2 devices, only these 2 devices, what you can do means you can supervise whole detectors, you can supervise whole sprinklers. So there is one control module also. So I think control modules are operating, or they are supervising all the monitor modules. Suppose if there are 10 monitor modules, if any fault in monitor modules, the control module will monitor, but I cannot find the control module. The best way to find control module is this. We will see the abbreviation control module.
It is an IFU. IFU, it is control module or input module, IFU. If you go to symbol IFU, you go to IFU, see?
Interference output or input?
This is interface output.
That is the different one. Interference output is the different one. And that is also not given anywhere.
The control module is also interface output because it will give 24 volts sometimes DC.
Okay.
It will give
ESF, electric sounder and flasher. Okay, this ESF is the horns strobes actually. B is the bell monitor module for sprinkler, horn, duct, smoke detector. Control module is CM. Let us try to find the CM. Let us try to see here. This is the IFU. What you are telling, it is connected in the roof. All these things are connected with the fans actually. All the fans, everything is connected with IFUs. And then it is coming to the mechanical room. Zone control, CM is not given anywhere. So maybe they have not used this thing. Here left side you see all the speakers are connected. This is the speakers. 20 speaker, channel 1, channel 2, channel 3, like different speakers are also there. So those are connected here. They have shown the channel system. So this is the speakers. And after that here what they have given, unswitched fuse per unit 12 volts battery, interface with BMS.
What is mentioned in the drawing? What type of a speaker cable they are using? Speaker cable. What type? Can I see please boss back in the drawing? Speaker.
1 mm square cable. They have not.
It should be fire rated also. Speaker cable should be also fire rated.
Fuse per unit unswitched 230 volts and 300 watts they have used. 1 square mm cable is used, but they have not written anything which type of cable is used.
And sir, the in speaker in PA system, there is nothing, any cables coming from anywhere to panels and return panels.
This is the only cables, no? Like one is incoming, one is outgoing. See, incoming is going here, and this incoming is going, and it is charging to our control, MCP, And with this as MCP, it is connected to the detectors, interference unit, monitor module, everything. And just if you follow, the same thing is like going back, and it is coming here. It is connecting with this something isolator base. Then again, this is going back to the fire alarm control panel. So one will be the input device, one will be the output device. So output devices will be in the form of what you can say horn strobes or any ringing alarm, those things. The input devices will be our detectors, manual call points, monitor modules. Just by seeing one loop, you can understand. And here you can see how they are following. Just follow how they are following. And in the output location only, they have placed this sounder alarm. So different names are given here. So whatever the names, so this particular names will be is very important actually. Whenever you are doing any fire alarm or design, so these names are very important actually. Something is given here. If you know which type of like they have used, so what you have to do means you have to just follow this particular document to connect the devices. Like here, I have written here Morley notifier Edwards, and I will also share, and I think I have shared with you this particular 1 minute. There is one notifier folder is also there, so just you need to check that also. 1 minute. This hand actually. Minute. Yes. See here, I have shared one notifier folder also. You can check this folder also. In this, just I have like taken some of the technical specification of the different devices like monitor module, fire alarm control panel. Different things are given actually there. Just a minute, it is. Not that opening. So anyhow, a big topic actually. Almost it is 300 to 400 pages. See here, this is the notifier. I've just written some like modules, panels, speakers, and different like things are given here. So you can just check this. First, let us close this AutoCAD drawing. It is creating some problem here. Okay. If you see this NFPA 72, so in this NFPA 72, there are so many things actually. It's almost 347 pages. So, and there are certain limit, like there are certain what you can say, the clauses only written here. So whatever the clauses we have to follow in as per NFPA 72, those things are written here. So I think we will see this in our next class, because it's again we have to just check this also document. So we will see in like tomorrow only we will see, or if possible day after tomorrow we will see. Anyhow, we will see this also, because this 72 is also a little bit important. So there are certain points given in NFPA 72. So we just need to dig out those things also. So it's better that we take another class for this particular topic. And with this topic also, we will see this stairwell pressurization also. Actually, this stairwell pressurization is also what you can say, it's an independent topic actually. Sometimes the HVAC people will do, sometimes firefighting people will do, sometimes a new consultant will emerge and they will do the stairwell. And there is one document actually with this and some calculation procedure. So we will see that also. And after that, we have one more elite class. Okay. So I will just